Welcome to sunny South Australia. It is actually raining today, so I'm not doing a David Attenborough on a rock in the backyard. A month ago, I was on a GSA excursion in Reedy Creek Gorge. The igneous and structural geologists were discussing subduction in the Delamerian, while I was pondering what had gone down the gorge and flooded out onto the plains of the Murray Basin. I was last here 50 years ago as a student, and that is my honours supervisor Pat James over my right ear. Some of you will know that I've been talking about copper gold targeting in the Gawler Craton, including the use of the data from the National Geochemical Survey of Australia. After presenting this year at 3 virtual conferences and a workshop run by the State Survey, I am retrospectively calling that part 1, and it is time for a change. I've moved on to assessing the NGSA in the Delamerian. As I've done in the Gawler, I am starting with the known on the eastern side of the Mount Lofty Ranges and working into the shallow covered western margin of the Murray Basin. I see these scenarios as the next level of exploration challenge, as the industry has been poor at exploring through even thin cover. Having discovered White Dam in Paris using regional chemistry, I have the view that exploration geochemistry is underdone in Australia, hence my interest in the NGSA. I had noticed some interesting results in these 3 NGSA sample sites. My attention was further diverted to this area by Graham Carr, a former research leader in CSIRO and a long-term friend. Graham is supervising a PhD student who was applying lead isotope analyses to anomalous NGSA samples. He asked me what I knew about lead deposits around the site near Strathalbyn, as I led the Aberfoyle team in the Angus discovery in 1992 and had undertaken considerable collaborative research with CSIRO there. That got me thinking, and I decided to spend some time looking further into the Delamerian. Now, this is a beautiful image. It is a digital terrain model that drapes much of South Australia's 2 billion year geological history in this part of the state. And it still speaks to us as geoscientists raise new questions about how things formed and what is yet to be discovered of our resource wealth. The image is from SARIG, the internationally acclaimed geoscience data system managed by Christy Gerard for the Geological Survey of South Australia. Many of the images I am showing today are courtesy of SARIG and also Geoscience Australia's Atlas of NGSA maps. These demonstrate the value of such excellent websites in enabling IT immigrants like myself to develop and communicate our ideas. I will unashamedly talk about relevant geological experiences going back to my early childhood in Naracoorte and how these mapped out my career and are still contributing to my thinking. I am doing this with the aim of encouraging younger viewers to appreciate the passion and joy geology will continue to bring people who want to apply their brains to earth science. This will continue to lay the foundation for many things, including the questions and avenues that data scientists and AI need to crunch numerical geoscience data. I say this having successfully worked with the world-leading Australian Institute for Machine Learning in gaining second prize in the Explorer Challenge run by Oz Minerals in 2019. Geological thinking is a mix of science, art, intuition and detective work that integrates a complexity of data and thoughts that no computer will fathom on its own. I present this story as an example. I will mention volcanoes, limestone, fossils, historic smelters and some of my exploration experiences in South Australia in unravelling the NGSA data in the Delamerian. The results have produced more questions than answers. Both may be of interest to researchers and explorers, including the Geological Survey, as it manages the current NDI MinEx drilling program in the Delamerian. I also take the opportunity to discuss ways to improve the national discovery rate. This is a key input towards firming up our international competitiveness to supply mineral resources, not only to the world but to ourselves for value-adding opportunities. Here we are at Naracoorte with my grandfather in the car out front of his shop. He was Scottish and obviously only dealt in cash. The Naracoorte caves and fossils in the walls of our house, both in Gambier limestone, turned me into a geologist by the age of 9. I would cycle 7 miles to crawl around the caves, play cricket amongst the pine trees and make forts out of the pine needles. My best friend became a forester. Another became a renowned horticulturalist who managed some of the first vines planted at Rattenbully in the Terra Rosa, developed over the Gambier limestone. The landscape shaped our lives. I was excited to hear stories about the 1956 discovery at Naracoorte Quarry of the bones of a saber-toothed tiger, as it was described. However, I was moved to Adelaide just as the broadacre vines were being planted at Pathway, At the age of 13, I satisfied my thirst for fossils by riding a push bike over the hills and down to Mannum along Reedy Creek. The photo top left is my daughter's school project using the remnants of the 1968 Mannum collection. Then in 1969, more Thylacoleos were found in a cast chimney at Henschke's Quarry, a mile from town, and the megafauna were discovered in the floor of sediments of the Victoria Cave. I went back to visit the fossil dig as a tourist in 1971 and discreetly grabbed a tissue full of cave sediment from a pile and put it under a microscope back in Adelaide to see the sample contained about 80% bones. I thought I'd picked up some sort of concentrated sample. In 2019, I returned to Naracoorte with a geology group, confirming the cave floor sediments did indeed comprise about 80% bones. The megafauna and I now look more like Star Wars characters, and the World Heritage status had turned the loved pines into flowering gums. No one asked me about my heritage. After the Tom Sawyer childhood, I graduated from the University of Adelaide and explored around Australia. In late 1986, I was asked at a project generation meeting in Melbourne where could Aberfoyle find titanium and heavy mineral deposits, as the Pacific coast had been all taken up. I referred to my childhood and suggested the fossil beach strands of South Australia. Within a month, Mark Teakle had found the wind-blown sands at Paponda and went on to discover Mindri later in 1987. At that time, the WIM 150 discovery near Horsham was still confidential between CRA and the Victorian Government under an exclusive large tenement arrangement. In 1988, I was given the role of Regional Exploration Manager for Central Australia and I moved back to Adelaide. Aberfoyle was already on the way to becoming the largest explorers at Broken Hill in South Australia for a while. Aberfoyle found a number of heavy mineral deposits on the Paponda-Mindri line, as well as along the Nekaboo Arc in New South Wales and at Wemmen on the Victorian side of the Murray River. I built on Mark Teakle's model for the Murray Basin by proposing two proto-Murray River mouths, progressively advancing and depositing mineral sands near their mouths along the Mindri and Horsham trends. Then around 4.5 million years ago, an uplift with the newer volcanics down Mount Gambier Way tilted the Murray Basin and coalesced the rivers into the current course of the Murray River. This ran into the Flinders Ranges and with the loss of energy dawdled through the western ends of the strand lines out into the early Coorong. The limestone coast no longer produced heavy mineral deposits, but instead made the beloved Naracoorte Caves and Terra Rossa. In 1990, Steve Totef came across a petrographic reference to garnite near the 1848 Strathalbyn lead mine and proposed exploring for metamorphosed stratiform deposits in the 500 million year Kaman-2 group metasediments. I found $20,000 discretionary funds for an exploration licence and his time. Steve came back with a classic gossan that turned out to be spoiled from an infilled and unrecorded inclined shaft located to the right of the drill photo. Another indicator of the Angus target was on the southern side of an intervening effluent pond where BHT-style garnet sandstone was exposed in a low road cutting beneath tertiary cover of the infamous Gambier limestone. The soils near the shaft ran up to 1% lead. On the western side of the railway cutting, historic ore, rich in mercury, formed the foundation of a Besser block incinerator. Someone had the Strathalbyn mine in their backyard. Even worse, just to the north, a lady fell down their historic mine and was rescued after 2 days, when she did not turn up for work. On the other side of the quarry, at the base of the limestone cap, we found heavier limestone with the fossils replaced by sericite and smithsonite and assaying up to 45% lead and zinc. I willingly named the prospect Angus after George Fife Angus, not only for his early lead-zinc mining near Glen Osmond, but more importantly for importing 2 boatloads of Silesians to start the state's wine industry. After some diligent baseline environmental work to establish prior contamination by the effluent pond draining into the Angus River, we drilled and made the predicted lead, zinc, gold, silver discovery. Aberfoyle was awarded the 1992 National Explorer of the Year by the Australian Register of Mining. As at Menini Dam, Aberfoyle did a lot of lead isotope hydrochemistry and mercury gas detection studies with CSIRO. Aberfoyle used the model of a metamorphosed, highly structurally remobilised and coarsely recrystallised distal volcanogenic deposit based on the lead isotope and mercury signature of Angus. Steve followed the metamorphosed magnetiferous horizons northwards, through Will Ellen, Eclair and on to Kaman-2. At that time, Kaman-2 and Eclair were designated as university mines and excluded from exploration. In 1993, my last full year with Aberfoyle, we tested an accelerative horizon at a prospect southeast of the Kaman-2 mine, intersecting anomalous gold. The Kaman-2 copper deposit is now considered younger than the enclosing Kaman-2 group. So current holder Hillgrove's Resources may be on the right track with deeper exploration of the same prospect, now called Stella, as an epithermal deposit. Models may change, but the intent remains the same. You have to be in it to win it. Iterate, then iterate again, as long as you are making progress. I farmed MIM back into Aberfoyle's ground to complete the White Dam gold discovery and lay the foundations for the Paris silver discovery by Investigator. In both cases, the successful search tactic was regional soil geochemistry. Hence my appreciation in this country's underdone application of exploration geochemistry and interest in the NGSA dataset. So what is the NGSA? Around 2005, over 1,000 catchments were sampled across Australia, with one site representative of outflow sediments for each catchment. 2 depths were sampled at each site for 2 size fractions, each assayed with 2 digests plus MMI on the upper coarse fraction. This makes 9 analyses for each site for 59 elements, resulting in over 600,000 analyses. This is a valuable data set that I believe still has more to give. The application of local knowledge will maximise guidance for modern statistical methods, including AI, to handle such a complex data set and diverse geological, geomorphological and environmental settings. I'm currently working on a couple of anomalous catchments to support copper-gold exploration in the Gawler Craton. In retrospect, that was part 1, presented at the Hilda workshop run by the survey a few months ago. The GA Atlas provides statistically classified anomaly maps for each element of all sites for each fraction and digest. An example legend is shown here for a bottom course soluble analysis of uranium. For this study, I'm largely using the outliers beyond the statistical upper fence as being nationally and highly anomalous. GA has also applied evaluations to metals in catchments above the 75 percentile. Both classes are valuable, as I will show later on. My approach is to simply use the GA maps to determine catchments worthy of follow-up. The 2 maps on the left are examples of anomalous ISCG pathfinders in the Gawler Craton. The catchments over the Kaman-2 Delamerian are also anomalous, as shown in the 4 examples on the right. The Bremer site is lead anomalous, and the Reedy site is copper and gold anomalous, in good company with anomalies in the western succession of Mount Isa and the Victorian goldfields. As an aside, the line of dysprosium anomalism across the continent appears real and is matched by cerium and yttrium. This is worth investigation, with one thought being back arc settings for a 1.6 billion year subduction zones. For this study, the Bremer and Reedy catchments on the western side of the Delamerian belt were used as templates, having a fair bit of outcrop and knowledge. I had assumed that these samples had drained from Angus and Kaman-2 respectively. However, my rough plots of the NGSA catchments did not look right. These templates were then compared with the Karoonda catchment, entirely blanketed by the Murray Basin. Let's have a closer look at the data and the sample sites. The charts for the 2 NGSA sites show nationally anomalous elements for the algorithm of 9 analyses. Elements with the highest national value for all of the 1,186 catchments across the country are shown in bold. The Reedy Creek site is remarkable in having the highest national values for about 18% of the periodic table, including many rare earths. Not only is the catchment copper and gold anomalous, as has been seen on the Atlas maps, one gold result is also the highest in the country. The Bremer sample is nationally anomalous in lead, bismuth and arsenic, and also in cadmium as a likely proxy for zinc. Variations across these combinations may provide the first information on the sources or causes of the anomalism. For example, for the Reedy site, the coarse fraction has no anomalism except for gold in the bottom sample. Copper is only anomalous in the top fine sample. Both the top and bottom fine samples are anomalous in rare earths. Zirconium and titanium are only anomalous in the total digest. The rare earths and thorium remain anomalous in the fine fraction and soluble digests. In the Bremer sample, lead and bismuth anomalism are spread through the depth and size fraction samples. Cadmium is only anomalous in the top sample, and arsenic is only anomalous in the bottom sample. Before trying to analyse these data variations, let's visit those two NGSA sample sites for clues about the drainage dynamics and the sources. Perhaps not so surprisingly, after the environmental work, the Angus system drains south of the NGSA site and does not contribute to the Bremer sample, even if prior drainage to the east had been captured by modern drainage pattern. Note the vines on the left of the sample site. The site is at the northern end of the Langhorne Creek wine region, where we had a jolly good lunch during an Amira review at Angus. Having a closer look at possible sources, the Wheel Ellen lead zinc silver system flows into the Bremer catchment, about 10 kilometres upstream from the sample site. Although the historic mining footprint is small, there was a historic smelter at Wheel Ellen. Another possible source is the Eclair mine and smelter south of Kanmantoo, about 15 kilometres from the NGSA sample site. However, the copper smelters at Kanmantoo and Bremer are also directly upstream from the Bremer sample site, yet there is no nationally anomalous copper in the sample. This leaves the possibility the lead arsenic cadmium anomalism has an unknown base metal source under the same carbonate cover that hid Angus. CRA did locate zinc mineralisation in a drill hole nearby. Now off to the sample site in Reedy Creek, where the photo shows granites outcrop on either side of a deep gully. The DTM shows the historic Kitakula mine is 12 kilometres directly upstream of the site. Once again, there is no possibility of past drainage from Kanmantoo into the Reedy Creek catchment. The historic Kitakula copper gold mine and smelter are in the headwaters of Reedy Creek. Records show the smelter was built close to the end of a short mine life and is unlikely to have produced much smelting product nor contamination. Reedy Creek develops a gorge at the contact between the Kanmantoo Group and Reedy Creek Granite Complex before spilling out onto the Murray Basin Plain, where the NGSA sample was taken. Here is the geological setting and anomalous makeup of the Reedy Creek sample. As alluded to earlier, the algorithm of 9 depth, size fraction, digest analyses provide much of the story about this drainage site. The coarse fraction lacks anomalism, suggesting flooding by a local barren source, maybe quartz or rock gravel from the walls of the gorge. The exception is gold in the bottom sample. This is probably a single nugget, because the soluble digest is not anomalous. Zirconium and titanium only feature in the total digests, as expected for resistates. The analyses of the top sample indicate over 6% zircon and rutile, or equivalent, in the fine fraction, and 0.7% in the coarse fraction. The potential for ionic clays is worth considering. Some of the rare earths will be included in the heavies. However, the rare earth anomalism in the soluble digest of the fines indicate another rare earth source, with the possibility of ionic clays. This is supported by total rare earth values for the sample fractions and digests. For the top sample, the total digest has extracted about 7,000 ppm rare earths in the fine fraction and 300 ppm in the coarse fraction. This compares with 900 ppm and 160 ppm for the soluble digest, which is still quite anomalous. The original rare earth content of the bulk sample could be reconciled for the respective sample weights. Regardless, the anomalous clay load may be coming from a local deposit, preferably widespread and away from Reedy Creek. John Keeling proposes a 4.5 million year uplift stagnation model for the formation of the rare earth ionic clays at Rattenbully. That is not too different to the stagnation model proposed for the Murray River at the same geological time. The setting is therefore ideal for the standard ionic clay rare earth model, with plenty of underlying granites to source the rare earths and overlying clays to provide the host. Most of the drill holes around Reedy Creek were shallow holes drilled in 1974 for building materials under the defunct Monarto City proposal. On perusal, the historic logs variously describe clays and gravels. Although not assayed, a closer review of the drill logs would provide a valuable assessment of the clay distribution and a guide to further clay sampling for rare earths. The source of the heavy minerals is either directly from the adjacent granites or a Pliocene strand line, or both. A reminder of the rare earth accessories and heavy minerals is shown in the example of the Mindery suite. The strand line possibility is supported by DTM once again, showing that the Paponda strandline comes in from Karoonda at Reedy Creek and appears to deflect the Murray River. BHP drilled northeast away from Reedy Creek for mineral sands in 1994, intersecting up to 0.6% heavies. The thorium image shows subtle strandline trends, perhaps enhanced where intersected by the Murray River. The drainages off the ranges show thorium signatures. Reedy Creek and its northern shoulder are particularly strong. Is that a clue? While on these images, note the Black Hill Norite to the north. I will come back to this. So here is my revision of the catchments for the Bremer and Reedy NGSA samples. The next adjacent catchment sampled in the NGSA is Karoonda, with the catchment outline as interpreted by GA shown here in green. The anomaly analysis for the Karoonda site is shown as the top table. It is similar to the Bremer fingerprint, with corresponding arsenic, boron, cadmium and tungsten anomalism as shown by the blue circles. Karoonda also shows promising additional silver anomalism as shown in red. There are no smelters out here. The lack of outcrop and thickening tertiary cover in the Karoonda catchments has certainly subdued any geochemical response from the basement compared with the catchments on the western margin. The interdural drainage is vague. So this is another contrasting geomorphological setting, illustrating the challenge of comparing NGSA catchments across the nation. We are dealing with at least 100 metres of Murray Basin cover here. MIM found basement geochemical signatures can penetrate through at least 50 metres of unconsolidated cover at Ernest Henry and on the northern Yorke Peninsula. One possible issue is the Karoonda sample was taken close to the town. Another is the common assertion of contamination by agricultural fertilisers. Both are unlikely, as the Karoonda footprint looks like the Bremer one and does not look like a copper-rich fertiliser signature. In the 3 years of regional geochemistry on the Eyre Peninsula leading to the Paris discovery, at no time was there evidence for agricultural contamination affecting the surveys. Also, the Karoonda catchment is nationally anomalous in a dataset that would have similar nationwide issues, if these exist. GA has looked at the question of normalising diverse settings using statistical methods. However, as two of their authors said, a geochemical threshold merely draws attention to a certain number of sites that show unusual element concentrations. Further action must then be decided upon a case-by-case basis, requiring expert judgment. In this case, a simple adjustment for the cover is made by looking down at the next level of anomalism, that is, the plus 75 percentile group. A good example of why this can be done is GA's national map of one of the copper analyses plotted against copper districts shown in orange. Reedy Creek within the blue circle is one of only a few outlier anomalies, while the plus 75 percentile class, shown as crosses, match prospective areas such as the Mount Isa Inlier and the southern Gawler Craton. However, more covered areas like the Olympic ISCG belt and less covered areas like the Lachlan remain hidden, suggesting rapid dispersion and homogenisation of copper, resulting in few outlier anomalies. The table shows the Karoonda footprint livens up with the plus 75 percentile population. We see many of our old friends in the rare earths, plus base metal indicators in blue, precious metals in red and volatiles in green. Are these elements migrating through the unconsolidated cover sediments to produce telltale signatures, as we saw at Ernest Henry and northern Yorke Peninsula? Base and precious metal targets may be present. The expanded signature is not only encouraging for lead and zinc, silver, gold, antimony, mercury, boron, fluorine are prospective for epithermals, while selenium, tellurium, palladium, platinum and adporphyry or mafic hosted potential. Again, the lack of copper anomalism for these target styles is understandable with the obvious subtleness of copper in the GA map. So back to the catchment map. Now we have given geochemistry a shot, let's revert to our subsurface vanguard, geophysics. Magnetics shows two interesting areas within the catchment where prospective trends are mapped with better detail, indicating a shallower basement. The anomalous NGSA site is ideally positioned between the two target areas. Most of the drill holes are shallow, heavy mineral holes with little deep drilling recorded, especially in the higher priority northern target area. This area has linear trends similar to the patterns in the Angus Cam N2 belt. These target areas correspond with gravity highs, permissive for basement highs. A common adage of exploration is look for basement highs. Ernest Henry certainly poked 50 metres above the surrounding Cretaceous basin floor. And while we are here, note the Black Hill signature as we remember those platinum and palladium anomalies. Tom Wise and the survey crew are currently applying the coiled rig technology in testing such areas for the National Drilling Initiative. The objective of the coiled rig is to do rapid on-site testing, enabling flexible infill decision making. This will be a great result. I don't know where they're drilling around Karoonda, but I wish the survey success as they get as many holes down as they can. You will note that the 4 target areas I have raised today are largely covered by tenements or the NDI gazetted area. My ideas and area selections are not absolute. However, these are my initial ideas for exploring the region after reviewing the NGSA data. Many of the tenement holders are seeking different commodities to those in the proposed target areas. So here we see 2 aspects where I believe we can improve our resource discovery rate in Australia. Firstly, the lack of diversity in targeting by companies holding tenure and exploring for only specific commodities, deposit sizes, deposit styles in specific places, further delayed by funding sources and cycles. The second aspect is there is a reliance on government to test new ideas, particularly in the greenfields environment. I'm right behind the work like EFTF and NDI. However, it produces conflict with the tenement system. So the recommendations of this not quite fossilised megafauna are twofold. Firstly, on a technical level for the Delamerian, I suggest follow-up of the 3 catchments with detailed drainage sampling and geomorphology studies. These will assess firstly whether the NGSA sampling analyses are representative and of what catchment. Secondly, whether there are multiple sources to anomalies that may be mining heritage, geomorphological or even unknown deposits, and whether these can be distinguished. And thirdly, whether further target detailing is possible at the surface, even in areas of unconsolidated cover. The NDI drilling should make the most of the cover samples. These can be analysed to assess the metal mobilisation through the unconsolidated cover and the prospects of using shallow geochemistry as basement vectors. If it works, it will provide a larger footprint for target vectoring in the underlying basement. In this regard, the pending zircon and monazite characterisation of the heavy mineral sands cover may also provide valuable data on the physical dispersion from local basement sources. It is challenging to think of Pliocene islands pushing up through the Loxton sands, but research can produce surprises. On a more general and strategic matter, the slow speed of target development and testing will negate our international competitive advantage of supply. I suggest a well-directed community campaign is run for exploration geologists to adopt their local NGSA catchment and assess the effectiveness of the samples in representing that catchment, assess the targeting possibilities and recommend follow-up programs to extract maximum value from the NGSA dataset. That would speed up thinking across the wider Australia and add to the EFTF and MINEX programs applying specialist techniques such as airborne EM to selected areas. Government and industry should seek ways to maximise the testing of ideas and targets across diverse commodities, styles, models and tactics. The speculators won't like this, as the Collins Street risk profile is conservative, requiring sexiness of new technology stories and wariness of companies with multiple target commodities or styles. This translates into target testing limited in diversity and staggered to funding cycles. I recognise the frustrations and efforts of governments in implementing interest in testing new ideas and areas. However, the limitations of the tenement system also needs to be mitigated, with dual facilitation by integrators to address more targets within tenements. This is a more desirable option than the complexity of stratifying tenements to achieve diverse holders and target testing. Additionally, the opening of initiatives need to be slick to avoid explorers holding off drilling in the anticipation of government funding. So there you have my thoughts on the Delamerian and more. This may have been useful or provocative for some of you, and I welcome your feedback. Regardless, I hope you found this entertaining and will continue to appreciate the geologists in our community. A list of references follows with the thought that not all frontier ideas are launched in peer-reviewed papers. Thank you for your interest.